Hello, everyone. My name is Yevgeny, and today I'd like to share our experience at Checkmarx of how we embedded our own application security platform, Checkmarx One, into our development processes. It is a long journey that we still keep improving and working on, and I'd like to share what we learned along the way. Let's start with the why. We all want to build secure applications. The problem is that application security often lives in a silo. It's often bolted on to the SDLC rather than being built into it. This can create friction, delays, and even tension between security and engineering teams. In addition to that, staying compliant adds extra pressure as requirements need to be met within strict SLAs. As we build security into our own processes, we had four goals. First, we want to shift security left as much as possible. Make it part of the development, not a final gate. Also, we want to stay agile. Security shouldn't mean sacrificing developer speed. We can't have developers complaining that there is no time left for security. We want to stay compliant. Our software must comply with different requirements and standards, including meeting FedRAMP requirements, which are some of the most rigorous out there. And finally, we want it to be seamless, be as automatic as possible so that developers won't feel burnt out by security fixes. So how do we build it? In Checkmarx, we build automated scripts and processes to help our developers work faster. Some people call this an IDP, an internal developer platform. So what is an IDP? An IDP is designed to abstract away complexity and empower developers to self-serve. A good IDP makes infrastructure changes, CI/CD, and compliance as automated as possible. Following this principle, implementing security needed to be just as seamless and automatic as spinning up infrastructure or deploying code. We made the decision to embed our own Checkmarx One platform into our own developer workflows, not just as internal teams, but as real users. We mapped our SDLC end to end and identified key integration points for security. The first one is source code scanning. We want to scan all the application code we ship. Our code has to be as secure as possible. Then we have dependency scanning. We want to scan all the third-party dependencies we use in our services. We don't want to import unsecure code that someone else wrote. We also want to do container and IAC checks. We want to scan our infrastructure as code files and make sure our deployments are as secure as possible. And we want to scan the actual containers once they're built to make sure nothing falls between the cracks. To do that, we need to update our CI/CD pipeline policies. We need to integrate scanning into our PRs as additional gates before merging, and add automated scanning after merges were done. We also want developers to think security as early as possible. So we need developer ID integrations for our scanners to allow them fixing things even before they open a PR. And finally, we want the pull request scan results to be as clear as possible and run automatically when changes are made to have a fast feedback loop. To do all these, we updated our DevSecOps workflows. Rather than forcing devs to go to a separate portal, we brought security insights to them, directly in GitHub and their IDEs. This was critical for adoption. We implemented pre-commit and IDE integration. Developers get real-time security feedback from our various security scanners in IntelliJ, Golang, and VS Code before pushing code. We implemented CI pipeline hooks to integrate security scanners. PRs trigger scan and results are posted back into GitHub with actionable comments. We created risk-based policies. Not all findings block the pipeline. We use risk-based threshold tied to compliance. And finally, we made sure that we have dashboards and automated Jira tickets as we want engineering managers and AppSec to get visibility into trends, hotspots, and track security patching. One of our goals was to achieve security without compromising developer speed. To do that, we tweaked our processes as we matured our IDP. First, we decided not to block PRs and low impact findings and made sure our policies focus on higher risk findings to reduce low impact finding noise. Then, with feedback in both the IDE and the PRs, the developer considered security as another layer of testing that has to pass before release. They get initial feedback very fast. Eventually, we found out that more secure equals more efficient. We have fewer last minute blockers as we had less security issues that were caught late. These are much more disruptive than those that are caught early. We have less context switching. Developers fix issues while code is fresh, not weeks later. We have streamlined our triage process. Most of the findings were automated and actionable, and reduced back and forth with AppSec teams. And we have faster audits and compliance as we build in evidence generation that saves time during reviews like FedRAMP. Speaking of FedRAMP, our security processes were truly tested when the FedRAMP audit came along. We had to prove to a third-party assessor that our security controls were documented, tested, auditable, and continuously enforced. Because of the workflows we built into our processes, we didn't need to scramble to generate evidence. Our pipelines were the audit trail. We had a few key success factors for this. We had immutable logs of every scan and commit. We had evidence of policy enforcement on PRs. We had role-based access controls tied to our identity provider, and we made sure that the right people have the right access. And we also partnered with additional security vendors to secure underlying infrastructure, things like custom MIs and Docker-based images, all part of the joint effort to build secure software. The journey wasn't all smooth sailing. We keep improving and learning, and here are a few lessons we learned. First, developer experience is everything. If security feels heavy, devs will find workarounds and just not do it. It's crucial to invest in integrations, fast feedback, and clean UX. Security can't cause friction. It's crucial to make security as frictionless as possible. With the right abstractions and automation, security can actually accelerate delivery speed by catching issues early. We learned that context matters more than alerts. Scanning is just the start. Developers need remediation guidance, not just alerts. We need to offer fixed guidelines, things like what version to bump to or where to go to look for possible fix. And finally, ownership must be shared. Developers own code, quality, and that includes security. But AppSec and platform engineers own enablement, policy, oversight, and automation. So what should you take away from this talk? Security should be built in, not bolted on, and be part of the process, not an afterthought. Your IDP can be a powerful vector for scalable, frictionless DevSecOps. The time invested is definitely worth it, if done properly. Real-world usage for your own software is the best way to refine both your product and your culture. We improved and keep improving our own software because we use it extensively. And finally, aligning AppSec and developer experience isn't just possible, it's necessary for productive R&D organization. Thanks for joining me. If you want to chat more about how we did this at Checkmarx, feel free to reach out and enjoy the rest of your conference.